Hello students. Hello and welcome to this video on binomial theorems and expansions. In this video, we will solve question number 131 to 140. I will show at the end how we can download the PDFs and maintain an updated copy. The link to the PDF will also be in description. As well as at the end, I will also show you my question answer website, which I have developed for you, where you can come and ask questions related to mathematics. So without further ado, let's get started. So we were solving questions up to 130 in the previous video. 131 relates to this identity, which says that if 1 plus x square to the power n is equal to a0 plus a1x plus a2x square up to a2n x to the power 2n, then we have to find the value of this, that is a0 plus a3 plus a6 and so on up to a2n x 2n, and this sum would be 3 to the power 2n minus 1. So what we do is we put x is equal to 1 omega omega square, which gives us a0 plus a1 plus a2 and up to a2n is equal to 3 to the power n. We put it's equal to omega. So when we put 1 plus omega square will be 0. So it becomes a0 plus a1 omega plus a2 omega square plus a3, because omega cube will be 1, and so on. And the sum would be 0. And then we have a0 plus a1 omega square plus a2 omega 4, which is actually omega, plus a3 omega to the power 6, which will become a3, and so on. And adding, we get 3 times a0 plus a3 plus a6 and so on is equal to 3 to the power n. And that's why a0 plus a3 plus a6 and so on will be equal to 3 to the power n minus 1. Question 132 says that if Sn is equal to 1 plus q square up to q to the power n, Sn prime is equal to 1 plus q plus 1 upon 2 plus q plus 1 upon 2 whole square plus so on up to q plus 1 to the power upon 2 to the power n, q is not equal to 1. Prove that n plus 1 c1 plus n plus 1 c2 s1 plus n plus 3 c3 s2 and so on up to n plus 1 c n plus 1 Sn is equal to 2 to the power n Sn prime. Now Sn is given as this, so sum of the geometric progression would be 1 minus q to the power n plus 1 upon 1 minus q. And similarly, sum of Sn prime, when we do the geometric progression sum, it would be 2 to the power n plus 1 minus q plus 1 to the power n plus 1 upon 1 minus q times 2 to the power n. Now we write down the given series which is given for us. We can write it as n plus 1 c1 1 minus q upon 1 minus q plus n plus 1 c2 1 minus q square upon 1 minus q and so on up to n plus 1 cn plus 1 1 minus q to the power n plus 1 upon 1 minus q. We take 1 minus q outside. It becomes n plus 1 c1 plus n plus 1 c2 plus n plus 1 c3 up to n plus 1 cn plus 1 minus cn plus 1 n plus 1 c1 q plus n plus 1 c2 q square and so on. And we add this, it becomes 1 minus q times 2 to the power n plus 1 minus 1 minus 1 plus q to the power n plus 1 minus 1, which is equal to 1 minus q times 2 to the power n plus 1 minus 1 minus q to the power n plus 1, which is equal to 2 to the power n Sn prime. Question 133 says that find the number of rational terms in the expansion of 4th root of 9 plus 6th root of 8 to the power 1000. So we let the general term be tr plus 1. So tr plus 1 would be 1000 of cr, 9 to the power 1000r minus 4, and 8 to the power r upon 6, where r is 0, 1, 2, 3 up to 1000. So note that this is r plus 1 as term, so r will start from 0 and go up to 1000. Now for the rational terms, r has to be multiple of 0, 6, 12 and so on up to 96, because it has to be divisible by 6. And 1000 minus r should be a multiple of 4, because this is 1000 minus r and in the denominator we have 4. That is equal to 0, 4, 8, 6, 12 and so on. Now the LCM of 6 and 4 is 12. So the number of terms would be actually 84 when we divide 1000 by 12. you will get 12 8 are 96 and 40, 12 3 are 36, so 483 and plus this 0, so 84 terms. Similarly, question 135 is find the sum of rational terms in the expansion of cube root of 2 plus fifth root of 3 whole to the power 15. So the r plus 1 term is given by 15 CR 2 to the power 15 minus r upon 3 and 3 to the power r upon 5, where r is 0, 1, 2, 3 up to 15. Now for the rational terms, r has to be multiple of 5, that is 0, 5, 10, 15, and 15 minus r should be multiple of 3, that is 0, 3, 6, 9, 12, and 15. The common values will depend on the LCM of 3 and 5, so there are two terms which will satisfy this criteria, that is first term and the last term. And thus sum would be, we have to find the sum of rational terms. Sum would be 15C0 to the power 5 plus 15C15 to the power 3, that is 32 plus 27, and that is 59. Question 135 says that determine the value of x in the expansion of x plus x log x with base 10 to the power 5 if the third term in that expansion is 1 million. 1 million is 1,000 or 10 lakhs in Indian number system. So T3 in the expansion is given by 5C2 x cubed times x squared times log x with base 10 whole square is equal to 1 million. So that is equal to x to the power 5 log x with base 10 whole square is equal to 1 million. Now we solve this equation, you get x is equal to this. This is, yeah, this is correct here. 5C2 would be 10, right? So 1 0 is cancelled. Now this is 100,000, so x is equal to 10 here. So when you put x is equal to 10, this becomes 100,000 and this becomes 1. Question 136 asks us to expand x plus 1 minus 1 upon x to the power 3. So we let x minus 1 upon x equal to y, so 1 plus y cube is equal to 1 plus 3y plus 3y squared plus y cube, and we substitute it back. We get 1 plus 3 x minus 1 upon x plus 3 x squared plus 1 upon x squared minus 2 and x minus 1 upon x to the power 3. So expand this x minus 1 upon x to the power 3, we get finally x cubed plus 3x squared minus 5 plus 3 upon x squared minus 1 upon x cubed. Question 137 says that find the value of x for which the sixth term of the square root of 2 to the power log 10 minus 3 to the power x plus fifth root of 2 to the power x minus 2 log 3 whole to the power n is equal to 21, and coefficients of second, third, and fourth terms are the first, third, and fifth terms of an AP. Given base of log is 10. So it is given that coefficient of second, third, and fourth terms are first, third, and fifth terms of an AP. That is, they are in AP. First, third, fifth terms are AP means first term would be A, third would be A plus 2D, and fifth term would be A plus 4D. So they will be essentially in AP. So coefficients are there. So we write down the coefficients. So we have 2mc2 plus mc1 plus mc3. We solve this, we get m square minus 9m plus 14 is equal to 0. That is m is equal to 2 and 7. But it cannot be 2 as we have more than 3 terms. So m is equal to 7. Now once we have 7, we are supposed to find the value of x. Sixth term is equal to 21. So find sixth term, 7c5, okay, and then this square root will be all gone here. It will be 2 to the power log of 10 minus 3 to the power x plus x minus 2 to the times log 3, which is equal to 21. You simplify and solve, we get x is equal to 9 and 1. 3 to the power x is equal to 9 and 1, so x is equal to 2 and 0. Question 130, there might be a mistake here, okay? I'm not very sure. So it is sixth term, right? Yeah, it is correct. Looks good to me. Question 138 says that find the value of x for which the sixth term of the expansion to the power log of square root of 9 to the power x minus 1 plus 7 with base 2 plus 1 upon 2 to the power 1 upon 5 log of 3 to the power x minus 1 plus 1 with base 2 whole to the power 7 is equal to 84. So we write down the T6, we get 7c5 square root of this can be written as square root of 9 to the power x minus 1 plus 7. So that becomes squared, and this will be raised to the power 5, right? So when it will be raised to the power 5, this 1 upon 5 will cancel, and this will become 3 to the power x minus 1 plus 1. So that is equal to 84. We have got 9 to the power x minus 1 plus 7 upon 3 to the power x minus 1 plus 1 is equal to 4. If all this, x will be equal to 1 or 2. I know I skip a lot of steps, but it is expected of you to solve such equations. Now 139 says that if n is in the set of natural numbers, prove that 1 upon 81 to the power n minus 10 upon 81 to the power n times 2nc1 plus 10 square upon 81 to the power n times 2nc2 and so on up to 10 to the power 2n upon 81 to the power n is equal to 1. So we take 1 upon 81 to the power n out, common from everything. So we are left with 2nc0 minus 2nc1 10 plus 2nc2 10 square, and so on up to 2nc2n 10 to the power 2n is equal to 1. Now this is equal to 1 upon 81 to the power n, and the series inside the brackets will be equal to 1 minus 10 to the power 2n. And that is equal to minus 9 to the power 2n or 81 to the power n. So it gets cancelled and the answer is 1. Now we come to the last problem of the set. We have find the value of limit n tends to infinity. Fn is equal to cn minus 2 upon 3 cn minus 1 plus 2 upon 3 squared cn minus 2 up to minus 1 to the power n 2 upon 3 to the power n c0. So this will require understanding of concepts of limit. If you're not studied calculus yet, you can skip the question. If you have studied calculus, well and good. So we know that CR is equal to CR is equal to Cn minus R. This is essentially MCR is equal to Mcn minus R. So we can rewrite the given series as limit n tends to infinity Sn. Sn is missing here. I mistyped it. C0 minus C1 upon 2 upon 3 plus C2 upon 2 upon 3 whole square minus C3 upon times 2 upon 3 to the power cube and so on. That is what is given here. And this series is essentially 1 minus 2 upon 3 to the power n, that is 1 upon 3 to the power n. And if n tends to infinity, 1 upon 3 to the power n will be 0. So with this, we come to the end of 140 problems. I hope you enjoyed it. The easy problems. Now, I need to show you the website, not the channel. So the website is ashtabakra.org. I don't know why it is slow. It is still visiting that page. So this is the website. Okay. Second, third, and fourth links are algebra, trigonometry, and geometry, coordinate geometry. When you download, the date which you see here will not be there. So you need to add this date. And after 15 or 30 days, you come and visit the website again to see if the date has changed. If it has changed, you can download it. Okay, again, and add the date again. I cannot put the date in the actual file name because the links will be broken when I update them. So it is practically not possible for me to put the link. And eighth link is the question answer website. You can come to questiongeeka.ashtabakra.org. So this is the question answer website which I have developed for you. Again, I don't know why it is slow. Come on, it shouldn't be that slow. Something is wrong with my internet. Let me try this. No, there is something. Okay, it has come. Okay, so you can make a login here and come and join. I restarted everything, so seems it is not fine. It is not the problem with server, it is problem with my internet. Okay, questions. The backend is not responding for some reason. Okay, anyway, so this is the website I wanted to show. You can come and ask questions here. There are tags made for you. Tags are calculus, algebra, coordinate geometry, geometry, probability, and mathematics. So you can come and ask your questions up to class 12, and I'll be more than happy to answer your questions. So there is something fundamentally wrong with the internet, it seems. It is slow. Signal is pretty weak here. Okay. So you come and make a login here, and so if you go to kunjika.astrock.org and how to ask questions, I want to show you. Okay, leave it. I'll show it in the next video, okay, when the internet is properly working. So I hope that you have enjoyed this video and finding the playlist useful and informative. If you have not watched the entire playlist, the playlist is now more than 220 videos. So go ahead and watch the other topics. So what we have covered is logarithm, progression, complex numbers, polynomials and theory of equations, combinatorics, mathematical induction, and we are halfway through binomial theorems and stuff. After that, we will cover determinant matrices and miscellaneous problems. So it will be a while before we finish this, because if you see the miscellaneous series, we have 700, more than 700 questions in this. Okay, so it will last quite a while, okay? And you will have plenty of practice. So I'll end this video here, and thanks a lot for watching the video. I'll see you tomorrow in the next one. Have a great day ahead. Keep learning, stay curious, and most importantly, enjoy.